Hello everyone, this is practice exercise for Prismatic Machining. We're going to go ahead and start by setting up the folder. Now I do have a practice where I keep like a version folder that I copy paste whenever I need. So this would be a good practice for you to actually just have an empty folder eventually with all the different elements that are needed. So this would be good. So this is the exercise that we're trying to do today. We're trying to, whoa, that's a lot. We're trying to, oh, this is not the right one. So we're trying to actually manufacture this part. So what we're going to do first of all is we're going to design the part, design the billet, and follow all the different conventions that we talked about before. So let's study it. Look at the big dimensions. So like from the isometric view, we have this dimension, that dimension, and how much is gonna go up. So we have a 12 and 25, so that's approximately 37. I'm going to design my billet for 40, and we're gonna remove the surfacing 3 millimeters at the top if needed. And then we have a 60 and we have a 120. So let's go ahead and start by designing our billet at first. So part design and PRTRH billet V01, and we are going to create a sketch that is centered on the XY plane. We're going to create a centered rectangle. This centered rectangle, the dimensions are going to be, now of course the billet decision doesn't come like this. Usually what you do is you take a look into a catalog and you see what are the dimensions within a catalog that can make sure to you can start from them for your manufacturing process. So this is usually how we go about this, and we're going to pad it. And let's look again at the dimension. We have a 25 and 12, that's 37, and we said we're gonna add a couple millimeters for. So this is a good start for the billet. Now, of course, don't forget to put your reference elements. And the most important thing is we start with, oh, so very good. We have something called Z convention where all the material is below Z positive. So if this is my 0, 0, 0 in here, then my pad, it better be from the other orientation. Like this, all my part is going from the top. We're going to add a 50 millimeters along Z, just a point here for tool retract. Let's go ahead and call them the right way. So this is the tool retract. This is my programming reference, and let's go ahead and add a machine. So let's do the machine at 200 by 200. So somewhere here where the machine is gonna come to, actually that's too little. Let's be more realistic. And all right, so if we take a look now into where things are, we're saying that this is where the machine reset is to change the tool. This is the tool retract. Let's add a safety plane. Usually the safety plane is an offset from the XY value, and we try to make sure that it is somewhere along the tool retract point. So safety plane and machine origin. All right, perfect. Let's go ahead and change some of the graphics and to just, better illustrate some of the things. The safety plane, we do it yellowish a bit with the tool retract, and the machine origin, we are going to put it something reddish. All right, this is good. So we're doing good progress on the part design. On the references, I'm gonna define this as work in process. I'm gonna save this, and before I move forward to start designing the part, how do I have, oh, this is tutorial 12. What we have in here is tutorial 12.02, so parts, and we save our bullet. Before I move forward, I'm going to create an axis system. This will be good for manufacturing, and it's going to have, so I'm going to reframe on in here, and it's going to have Z, X, and Y that we are used to. So my axis system, this is going to be my programming. So all my programming is with respect to this one, and basically we're all set. I am just going to hide these planes so that it looks better. Save and file, save as, and now we're going to go ahead and do the part itself. So that's the second portion before we move on and start the manufacturing process. So this is the part. I'm going to hide the reference elements. We don't really need them, as well as the axis from here. You can actually even delete the axis if you want. I'm going to start by removing the 3 millimeters that we've added. So this is the part 25 and 22. I'm just removing this, but let's take a look into it. There's so many ways we can do that. We can actually, you know what? We'll remove 15, and then this is a little bit too many dimensions in the same location. That's gonna confuse me a bit, but that's okay. We'll power through. I think what I want to do is I want to remove not only the 3, but also the 12, so all the way 15 to come down at this level. Then I'm going to create this profile, and we're gonna do a multipath. So let's take an attempt at that. So double click on this one again, and we said we're going to remove all 15. So we went down to this level. Now I'm going to click in here, make sure that the part body is what is defined as working space, so that we're creating that. All right, so now what I'm going to do is I'm going to project this to my plane, and I'm going to make them, I don't know where is my icon, so which is to make it construction element. So I'm going to restore all contents and restore positions like this. Now I know where it is, and I'm going to make my projection as construction element. So sometimes it's better to do so. Sometimes actually it's better to project item by item like this, so that you can actually use them for dimensions irrelevant from each other. All right, cool. So now I have this. I'm going to create a profile that looks like what we have. Taking a look into this this dimension in here, this looks like there is like this radius and radius. All these radius are 5, and this looks like there's a distance here 8, 8, 8. So let's see the dimension. Dimensions are given are 40 for all of it, and it's centered around it. And from this dimension, it is 60. So I'm going to do these as straight lines, and then I am going to add the dimensions. Let's see, we have 12, 12, 12. This is good, and so on. Okay, good. So let's take a stab at that and see what we come up with. And it is centered along this axis. However, I don't really know where the center of it is, but looking into the dimension, it is distant 20 from the edge from here, and it is centered. So what we can do is taking a look into how much it was, all of it, or here, 60, so that's gonna be 30. All right, perfect. So let's go ahead and make a line. Let's make a line. Let's see. I'm going to give myself a boundary to work with. So I'm going to create a centered rectangle. I'm going to leave it as a construction element. I'm going to give myself a centered boundary here. And what I'm going to do is I'm going to put the dimension from here to here equal to this value that was 20, and then I am going to take this dimension that was 60. I'm just creating a boundary for me, and then this dimension that was 40. So this is like a boundary that I can use to actually have my part inside of it. And the same thing for this square inside of it. So this one is actually easier because this is centered and it's gonna be rotated like this, but there is a distance from this point to this point by 12. So we can try to create. Can we do it with an angle? Okay, we cannot do it with an angle. So let's see if we have another option. Yeah, let's do this. Okay, so we needed to create a point somewhere, or we can as simple as oriented rectangle. That's even better. Let's try this. Okay, that's not gonna like it at all. So I'm gonna remove all of these dimensions. All right, so I've repeated this several times that I like to do these things like live like this, so that you see also how I'm thinking. And I couldn't find the best way to create this centered square, but to create it completely from scratch, and to create it myself from scratch. And this is what I'm doing right now. So I am going to, first of all, make sure it's not a construction element, try to apply that they are all perpendicular to each other. So I'm going to create here perpendicular constraint. Make sure you activate those constraints once you restart creating them. Perpendicular constraint, perpendicular constraint. So what I'm doing is I couldn't find a feature to do it the way that I wanted to do it, so I am recreating it from raw values. This one and this one, I want them to be in coincidence. I want this point to be at the angle. The same thing as this one and this one, I want them to be in coincidence. So, and I already have that. Okay, good. So now all I have to do is put the dimensions of the 4 of them. Okay, so since they are perpendicular, we don't need to put all of them. We need to do just 2 of them, and it is 20. So we can do 20-ish and 20-ish. All right, perfect. And now finally, all we need is a dimension from here to this point, and that dimension is 12. All right, so we've got this centered, we've got this element in here. So I'm rebuilding everything in here. So we've got the centered point in here, and from this is the only one where we're gonna have to come up and create a certain flow, and we have all the dimensions of it. So the next thing is these circles. They are all distance of 8 and 5. So that's something easy we can do. We can double click here on circle and create this one. Oops. And another circle here. Yeah, I don't like when it creates automatically constraints on its own. So I'll just all right, now the second thing is dimensions. So I'm going to do something. I'm going to set all of them as equal. You can select all dimensions and click edit equivalent dimensions, and you can put the value. and going back into here, the radius, which I cannot see yet where it is. Okay, R2, so it's a radius of 2 millimeters. All right, so this is where I got it from. This is the radius 2 here, and now I'm gonna put the other dimensions, the 5 and the 8. So double click, we're going to zoom in from the center to here, that's a 5, and from the center to here, that's an 8. Same thing from here to here, that's a 5, and actually that's the 5 and that's the 8. From here to here, from here to here. All right, cool. Now we have the squares, we have the circles. Let's go ahead and make sure we put the dimensions that we have. This is, so we can, let's go ahead and apply what we just learned. We select all these values and we make them all equivalent dimensions, and we put 5, and then we select all the other values and right click, we made it edit equivalent dimensions, and we put them all equal. Let me verify 8, yes. All right, so we've got some of the stuff now from here. This is good. So we have this shape, we have those internal diameter, so we have to think about a tool radius. So the tool diameter has to be 4 in order to do them. And now let's go ahead and create this shape in here. What I'm going to do, this is 12, so I'm going to create a 12, and then I am going to go down along this line 15. You see this 15 in here, so I'm gonna go 12, I'm gonna go 15, this is 12, then I'm gonna go 12, and then in here this is 8, so I'm gonna go all the way up to this dimension, and then I'm gonna put 8 in here. So let's go ahead and do that, and then we are going to put the radiuses. So I'm going to click on profile, I'm gonna start from this point, and I'm going to move, as we've said, a value of 12. We're going to go back. So let me okay, they are turned off, so this is good. And then we're going to go back approximately 15. We'll put dimensions always in the end. We will come back here a little bit, we move all the way up, and then we come to this point, then we're gonna move to this point, to this point, and then to this point. All right, so this is the profile that we have. Since we are fixed on these points, this is automatically green. Now I want to make sure that these are vertical. Are they already vertical? Okay, so let's make sure. Okay, they are vertical. We can change their dimensions. And this one and this one, we have a dimension here, and then this one we have a dimension, and then this one has, okay, so let's start putting the dimensions. This is an 8, this is a 12, this is a 15, yep, 15, and then we have a dimension of, it's not telling me how much this is. So let's see together. I think we can calculate it easily, because if all of this is 40 and we have 12, 12 and 8, that makes this also an 8 along the horizontal. Okay, so we can make this as an 8 as an horizontal, and actually it would be good to demonstrate it. So I'm going to click on this dimension and right click, and you can click vertical measures like this. All right, so this has to be a horizontal, and voila, we have an ISO constraint sketch. Let's just make sure that we reflect 8 in here. Okay, so we forgot to put this one as vertical. All right, so what dimension did we put that did not like it? So if I remove this one for a second, oh, this one, how much was this supposed to be? This is supposed to be 12. Okay, we have created a constraint that is conflicting with this constraint, so we have to put this one as horizontal. I mean, this goes without saying. This one has to be vertical, and it's gonna be purple, no problem. I'm gonna see where is the issues coming from. Oh, I see the issue. We have the 40 and all of these values, and it's not liking it. So if we remove the 40, because we've based already on a 40, this is gonna like it. All right, cool. So this one is 12, and this one is 8, and this one is 8, and this one is 12, and I'm gonna verify that this is 40 by clicking on this one and measuring this value here. Okay, this is 40. Cool. All right, we have our sketch. This is good. Everything is included. We did not forget anything. All we need to do is put the radiuses, but we can actually do it within the sketch, or as we decided, I am going to, because these are all external, like from the outside. So what I'm going to do is I am going to fillet it with a radius of 5, like 1, 2, 3, 4, 5, 6. So it's just gonna like a radius of 5 because this is all of it is 8. We'll see what it creates. So let's go ahead and test it. And we go out of this. All right, so one of the good things about doing the sketch into one element is we can do multi-section solids. So these are through holes. So basically, we're not gonna extrude anything of this. Then this profile actually is only going to be extruded 12 minus 5, so that's 7. So we're only going to extrude this one as 7 and the other as 12. Let's go ahead and test it out and create a. So we have so many domains. This one is the outside one. So this one was the 12. I think we will verify soon. Okay, good. This one is the internal square, and that was the 7. Well, actually, our life is just easy because all the others we don't extrude them. Preview. Okay, and let's see. Yep, it looks super right. And what's missing is we are going to sketch. So I'm going to fillet all of these, even this one, like was 5, and we will see how it ends up being. So we have all of this, and fillet 5 millimeters preview works perfectly. We got it. This is our part, and we are ready for, let's go ahead, zoom all in, put it isometric view, and we are ready for the stage after. So we're going to, before we forget, because we took this from the billet, we are going to remove billet from here, part, and file, save all. All right, so we have the part, we have the billet, and next thing we want to do is create the manufacturing assembly. So let's go ahead and start with that. So clicking on assembly, properties, PRD, RH, manufacturing assembly for tutorial 12.2, V01, insert existing component, and let's make sure we pick the right folder. And what is this? Product process, product parts, and we insert our parts. So although we've been doing things the right way, so everything like even without any constraint right now, if I come and I put on in here my little graphics with some transparent colors, you can see that, hey, we got it right. But I don't like that. I prefer that we put assembly constraints just to make sure in case somebody else touches your file or somebody else changes something in it. We just want to avoid any of the any of these changes. So let's go ahead and create our manufacturing assembly. All I'm gonna do is I'm going to remove the billet from here. I am going to show in the part references because I like to use. Okay, then I'm gonna remove this snap to, or else it's gonna keep on doing it. I'm gonna bring this element here. I'm going to select the programming references and I'm going to make them coincident, so this is good. Now this can also leave it to rotate, so what I'm going to do is I am going to make sure that the angle between these ones are 0, and the same thing between this face and this face. I'm gonna put a 0 angle and a little Control U, and then I can hide my constraints because I don't need to see them. I just want to make sure that they don't get messed up. I am going to hide the machine so that the machine origin, so that actually I know it's there if I need it. Actually, we will hide all of these in here, and we will hide the machine origin in here. Like this, when we zoom in all, it does zoom in on the part that we have with the reference and everything that we need. All right, perfect. File, save all. Now we are ready to, I don't know what's asking me. File, save. And, oh, we did not save the product yet. So, yes, we want to save it. File, save all. And now we are ready for manufacturing. So, let's go ahead and move on to the manufacturing stage. So start machining, and we're gonna click on Prismatic Machining. As you know it by now, all manufacturing is the same way. First of all, you double click on part operation to define what is your machine, what are your different elements. And then the second stage that you do is, I'm going to hide the billet, is you start your operations. And there is no one way. There is, you can do this tons of different ways, and as long as you get the material that you want, all right, I'm clicking too fast, as long as you get the result in manufacturing that you want, you're fine. First of all, let's make sure we select the 3-axis CNC machine. I want you to make sure that you select a post processor. So and this is not a lathe, so we're gonna go ahead and select, let's go ahead and select the ICAM millimeters post processor table. We can put the NC type as ISO. This will generate us a G code. And so if in case we had a tooling catalog in the company, you can put it. I'm just gonna go ahead and pull mill and drill starter kit. Sometimes we have to modify things. All right, so this sounds good. And we click OK. We have the machine defined, the reference. So we have already created it. So all you have to do is come to the axis and just select it, and it will automatically take it. So that's the programming reference. The part, this is your part, very easy. The billet, you go and you select the billet from the design tree. A lot of time, if you don't put these, you're not gonna have simulation. So make sure that they are selected. And because we've used the right naming convention, we can see that it's billet for the billet, like, or the stock, whatever it's called, and part for the part itself. All right, some safety plane. Where did we put the safety plane? We did hide all our reference elements. So, and let's go ahead and unhide here. and we can select it from here or from there, and basically we are all set. If we need to do any changes, we can go ahead and come back and change them. All right, so this is for the part operation. I'm just verifying we're all good. Now at this stage we're done with, so you can see this is the resources list because we've selected this 3-axis machine. So we have it now saved in here. We're going to save the process file just so that we don't lose it by mistake. So PRCRH tutorial 12 exercise 2 V01, and yes, and we're good to go. So as I said, there are multiple ways to do this. You have to start thinking of it. If you remember, we had a 3 millimeters that we wanted to remove surfacing, but you don't really need to remove them surfacing and then do something else. So there is this function called prismatic roughing. I like it, this function, because it moves you from the roughing stage to the finishing stage. So basically it will take the axis along Z or along however you define it, and it's gonna try to remove as much material as possible. So let's go ahead and try it out. Prismatic roughing. So you can select the rough stock and the part. Let me go ahead and show the part again so that we can select it. So this is the rough stock. So and this is the rough part. And you see in here the orientation of the roughing operation. Now, this is very important where you take the strategy of how much tolerance you accept. And actually even the tool. So like you're using a tool that is a ball nose. So it has a ball, like it's not an end, it's a ball nose tool. So this tool has a diameter of 10 millimeters, which means these circles in here that were approximately 4 millimeters diameter. So the tool is not going to do anything in here there. So you're going to end up having to do some actual operations. And no problem about that. The tool that you decide and its dimension is going to create the best possible roughing for this internal shape for all of these, but it's going to leave scallops. Now, you can put, so there are so many things to define. First of all, this axis, if we wanted the roughing to happen along any other orientation, you can click in here and, like, for example, select the orientation. We got it lucky that it's along the right orientation. So basically all you have to do is select it and, you know, like just show how it is. And you see the orientation. It's very important that the orientation is properly selected. Now, you can say the maximum this tool can cut is 5 millimeters at a time, which means if you are going along this, if you're going along from this level, which is 40 to 25, you're going to have 3 passes. But also what this means is in here you have only 3 millimeters, so you have to watch out for the tolerance that you accept for this element. So in here, this value of tolerance is how much you're accepting to leave material, because you know you're going to be doing a finishing stage. So let's put this at 1 millimeter, and you can select helical, back and forth, whatever. Like you can play around with the options that we have. So this is the tool. I'm fine with this tool. So we can, if we don't want it a ball end tool, if we want it to be a different kind, we can accept to change it. I mean, you can remove the corner radius here and make it so you have to remove the ball end if you want to remove it. So now it's in like an end mill. So once again, it doesn't really matter. What matters is that the selections you're doing are the right selections for you. All right, this is tool number 1. In here, it's computed automatically. It's gonna go up and down, and let's see what it gives us. And if there's an issue, we will rectify with this. So this is how it's doing. So it's coming down. So I don't really like the ball nose tool for, prismatic roughing, perhaps an end mill tool, but it's fine. And it's coming down and it's doing all these, like it's doing 945 positions. So if we play it, this is what it's doing. It is creating a simulation of how it can do the roughing operation. So as you can see, it skipped completely the stage. It is now coming back to it, and it is creating those motions to the best possible. And you're going to see that the quality of manufacturing, so these are different levels, by the way, and you're going to see that the quality of manufacturing is not optimal. Let's see a simulation of how it is expected to look like. And that's totally normal because, first of all, we're doing a roughing. We're not doing a finishing stage. I mean, look at these dimensions, look at these scallops in here. I'm going to change one value in here, and I'm going to put it at 0, and I want you to see the difference, how it will be when you don't have this element. So you see a little bit the selection of your tool, what it influences. However, in here we have a straight edge. There is no way we can get this shape because the tool will always have a diameter. So what we will do is we will get a first shape with this one, and then we will use another one to get as close as possible. Let's go back just to demonstrate how much finishing actually is important. We are going to leave this as the first stage. We're going to associate this video so that we can actually play this again and again. And we're going to move on with another operation. So thinking of this second operation, we are going to go ahead and try pocketing on this side. So let's go ahead and start doing these different pockets. I'm going to try to use the same tool for this pocket and the others. If I remember well, the radius, let me take a look at the map, it's a radius of 2. So first of all, let's take a look at the different options of the pocket. So one of the options of the pocket is if it's an open or a closed pocket. This is a closed pocket, so it's closed from all the sides. I'm going to select in here, and then I am going to request that we find another tool, and that tool, we need a small diameter, a small radius, a diameter of 4. That can be good. All right, this is good because this same tool we can use to manufacture all. So let's make sure something else in here. This is 20 millimeters. So all right, let me explain my chain of thoughts. What I'm trying to do is this new tool, and you can see it popping up in here, is I want to use it for this pocket, but also for drilling these 4 elements. So let's go ahead and see if this works for us. And so we have this first stage, and now we're going to, okay, perfect. This is good. So we did this pocket. Now, of course, you're comparing. So, I mean, this is, let's go ahead and zoom. The tool is going to come along this orientation, and the tool is cylindrical. So no matter what, we're going to still be left with a fillet in here, whether the designer does it or not. And it really depends. If you really want to remove it, you have to try to use other operations, because milling, especially when it's closed from this orientation, will not get you there. I forgot to save the video, so let me make sure that I play again and I associate the video with this result. All right, perfect. For the stage, using the same tool, I am going to go ahead and do these 4 pockets. So it's a closed one. We're going to select this one. I'm not sure if I can select several of them at the same time. Let's see if I can. No, we can't. So is there a different operation? Well, we can do the actual operations. Okay, so actually let's do it the right way. So we can either do it as a pocket, it doesn't really matter, or we can do them as a actual operations where we look into the right operation. So you have the graphics. It really depends what it is that you want to do. These are like drilling a hole. So we can simply just perform a drilling operation, and the drilling operation, you will have to just select the boundaries of the drilling operation, and they would show you. And actually for drilling, 12 millimeters, that is correct. And actually for drilling, we can actually select several points at the same time. So actually it will go back and forth and do all of these operations. All right, so let's go ahead and see in here the tool. That's the right tool that's selected. Strategy, we can change if we want a through hole, if we want a clearance. So in here we know it is 12 millimeters. So let me verify that. Yep. So let's go ahead and see how it looks like, if the operation is good. I'm gonna press up and down here. Well, it is not showing the simulation, but it is showing it. Let's see the video. Okay, it did it the right way. Now, mind you that it moved along the surface. If we wanted to change the approach and retract, if we wanted it every time to approach to a certain point, so we can actually add actual motion. We can put it just 10 millimeters. I mean, this is sufficient. Let's see if it does it. So it did move up a little bit, the center. Let's see if this one, actually this is good. This is fine because we're gonna be doing surfacing. So we have the billet at the bottom, we have these dimensions, and we did the actual operation of drilling. Let me save the result of the operation. So if you see the coloring depends on which tool you're using. As long as you keep using the same tool, it's gonna keep the same coloring. So I'm gonna intentionally put a facing operation after this, and I'm going to intentionally use a facing. This is a facing tool, and we're going to select the facing operation at this top, and we're gonna see like the right simulation, and we're going to go ahead and perfect. So you can see in here we had this first roughing stage with this tool, then we did some of the pocketing from here. All right, cool. So now we're moving along. We can actually perform other operations. So we can say we have to do this contouring, profile contouring, to make sure we get the profile the right way in here. So, oops, I clicked on facing. Let's go ahead and click on profile contouring, and we do it after facing. So apparently for some reason I stopped saving for each one, associating them. It's okay, we can do that in a different time. So we can say it's a hard bottom, we can say it's a soft bottom, we can ask for a contour, we can change the faces. So this is the bottom, this is where it is, and this is the contour that we want. So let's make sure it shows from the inside. I don't know if it automatically picked it. No, it did. Oh, that's first of all, that's definitely not the right tool. So we need like a more of a appropriate tool. And then coming back in here, I'm going to remove all of this. I'm going to remove all contours, and I'm going to by boundary of faces, I'm going to select these elements as the guide. So there should be this one here, so we can navigate on all parts until a certain face, and I'm gonna do here. So we select all of this, and then we can select this one as a bottom. So let's see if that works. And this is how it's gonna look like. So of course the arrow tells you if it's the inside or to the outside. All right, perfect. So let's go ahead and play the video, and I'm going to change the tool in a second. And so, all right, it is perfect. So I'm going to remove the corner radius. So I'm gonna pick a tool without a corner radius. So going back in here, so we can actually say, hey, we don't want our tool to be a bull nose tool. We can pick another tool. So we've been doing radiuses of, I think 5. Yeah, 5. So diameter of 10 would work well everywhere, no problem on that, especially on this internal portion. Let's see if we need to change something else. No, we don't need to change anything else. Let's go ahead and play the video and associate the result. So before I continue and I finish up this last portion, I am going to revise all of my operations, and for each one of them I am going to associate the video for it. So this is good, this is done. We're going to do the pocket now, the first one, and we play this one and we associate this one. This is good. We're gonna click OK on this one. So all right, so this is also good for this operation. The facing, in case we missed it, and you can play the video from last save result, or you can always play full video. So you can actually decide you want to see like every single aspect. You want to see the roughing operation, you want to see after that. So now we are in prismatic roughing. It's gonna move afterwards to pocketing. So this is let's zoom in a little bit. All right, so now you can see the sequence in here and as it was moving. So I was in the facing operation, and finally the profile contouring that we've had. All right, so here we did this one principally to get this profile in here, and now we are left with finishing that face and these portions. So we could have done any of these before each other. So there are multiple ways we can do this. We can treat this as a pocket, actually, an open pocket. So we can treat this as a pocket. We can select this face and we can come and actually I think it automatically identified the island. Let's see that. Okay, so it did it, but I see some weird motion here. So we're going to see if actually this penetrates into the material and creates a problem. Yes, so you see in here, some of the issue we had is at one point it was moving. So let's see here. So this is, let's see which position is this one. So it moved back up and down. It reached a point. So it's somewhere, I'm going to say somewhere around the middle. And okay, so it's following the profile and it moved here. All right, and then it continued. So what we want to do is add a feature somewhere where we say the approach and the clearance and whatever you want to do, make sure you go up and you retract all the way up before you continue a certain step. And we can actually try to see in here, this is actual number of levels, no problem. This is good. Finishing, we can do like anyways, this is all the finishing process. I think this would solve it. So, and actually it did not solve it. So let's see a little bit in here. Offset on check, offset on check, offset on top, double. Okay, I'm gonna click on this point and try to see if this is the point that makes it go up. Yep, here we go, solve the problem. So we made sure we don't enter and we hit the material. All right, cool. Let's see how it looks like. Perfect. This is our part. We got all the different operations. Now you can change the tools if you want. You can, I mean, we did not really have to do this profile contouring the way that I did it. But I wanted to intentionally make sure that the surface in here is like, this is dedicated to that surface, and then I would do the pocketing. You can actually, you know, perhaps we can move the profile contouring and actually move it to become the pocket first. So let's see the video in complete replay and see all the operations that we have. So I am going to let the video play and we comment a little bit on this. So the first, oh, that is so quick. Hold on a second. So the first thing that we do always is a general roughing operation. This is what you're seeing in here. What we're basically trying to do is remove excess material, getting close to a certain tolerance, and then after that we start the finishing operation. And then what we start doing is we started changing the different tools that we have to start doing the operations. So we did this pocket from the inside. We're going to do all the drills, and then we did the finishing of that face at the top. But now we're doing some pocketing on the side, and finally a finishing contouring pass for intentionally for the side. All right, so the very final step that we have to do is just to generate the NC code. Obviously, this is something that if you have the right processor and everything. So in here we have like a virtual one. We have just one warning. We can see what is this warning, but we don't have any errors. And we can actually save all and open that code. So we saved it in the process. I can copy all of this and move them into the NC code portion. And this is the cat NC code file. We can open it. And you can, I mean, if you know to read the G code, you can see that these are all motions, and you can see like M6 is every time the tool has changed. Let's go ahead and do it this way. So we have tool 1, tool 10, tool 3, tool 4. So if we find M6, which is a G code function for tool, this is tool 1. Then after that, you see that like at this point, and actually this number 945, you can see it. I mean, with the steps, when we're doing the different steps, I mean, you can see the 945 positions. So basically each line in here corresponds geometrically to something there. Find next, this is tool 3. We can see in here, where is tool 3? Here, this one, this is for the face milling. So face milling operation, that's a very simple one. Let's go ahead and, okay, this one, cancel, open the face milling and click here. This is a simple 25 position, and you can see, I mean, the whole position is moving and it's going along the orientation. And where was the M6 here? Okay, here. So this is the tool. We set the spindle speed forward, we set the feed rate. Of course, A's and C's axes are 0. There is no angle tilting in here. And we go to a certain point, then we go Z minus 8. If you remember, this Z minus 8, it comes from the fact that of the programming. So basically we had like a certain dimension, and this dimension is what we are trying to remove. Then we go along certain values of X, and then we keep moving X, Y, because all this manufacturing is happening along the plane. So all of these are just XY motions, and you can see XY motions all the way until we're done. And then we retract all the way to Z50. And then we move on, we reposition ourselves, and then we continue with our operation. In here we are changing a tool, so we go to somewhere to like very, very safe, and we are changing to tool number 3. Tool number 3 is the one for, actually we were reading the wrong line, because T10, this is the pocketing here and drilling. Okay, so I was reading the facing operation. Actually this is, so T3 face mill D50, that's T3 in here. This is the T3. And actually, to be quite honest, I was a little bit confused as yz minus 8. I mean, z should not be minus 8 at the surface in here. So let's bring this one. Actually, this brings me peace. So the value z minus 8, I can understand it from this 5 and the 3 on top, so that pocket. This facing is happening only at z minus 3. So actually what we should see in here is after this tool, after tool 3 is called, so after this line, we should see z minus 3, and now I am at peace with myself. This z minus 8, actually we're going down in the pocket of this one, internal one. So let me show you this one. If you remember, let's do it here so that I can do some. All right, if you remember, we have placed our billet at 40. So we have another 15 in here, and this is where we said z is equal to 0. So what this means, this value in here, we added 3 millimeters. So the facing operation is to happen at z minus 3. Z minus 8 is this value in here. So z minus 8 is this value in here. And this is the pocket that we were doing for this square in here. So now that we have it all good, and then we continue all the way till the end. All right, this wraps up this excellent exercise, excellent tutorial. Best of luck in doing it.